welcome to True Projects. In this video, we are going to explain about a project titled Computer Vision Based Method for Shadow Detection. Blindness affects many individuals due to various factors like birth condition, accidents, or the natural process. Shadows, a result of obstructed light, are a common occurrence. Interestingly, shadows can offer the insight into the approaching object, aiding in shape perception, occlusion understanding, and more. However, their inconsistent nature poses the challenge for the tasks like object detection, recognition, and positioning. This inconsistency hampers the accurate information extraction and the image enhancement. Thus, shadow removal becomes imperative for the precise object recognition and positioning. This process not only enhances the visual fidelity but also enriches the authenticity of image processing outcome. Despite the prior methods, the persistent relevance of the shadow detection and the removal underscores its significance in image processing, emphasizing the need for continued research and the advancement in this domain. Our objective is to introduce an innovative approach employing the artificial intelligence method for the detection of shadow in the images. This novel method seeks to enhance the efficiency of assistive technology designed for visually impaired individuals by precisely identifying the shadows. This has the potential to minimize the unnecessary directional cues given to the users. The proposed algorithm intricately detects the shadow along the user's path, leveraging the canny edge detection to pinpoint the object edges that aid in distinguishing the ground plane. By enhancing the shadow detection accuracy, this project aims to significantly contribute to the effectiveness of assistive devices, ultimately fostering the improved mobility and the navigation for the visually impaired. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. We need to import the essential libraries and packages including NumPy, Flask, OpenCV2. And the second one is exploring the dataset. Engage in thorough exploration of the dataset containing the shadow and the non-shadow images, investigating the properties and the labels to gain the comprehensive insight into the nature of the data. And the next one is image processing. Image processing techniques such as resizing, normalization, and the noise reduction is used to enhance the quality and the consistency of the images, optimizing them for the further analysis. And the next one is loading the pre-trained model. Load the pre-trained deep learning models such as YOLO v5, faster RCNN, which has been trained on the extensive dataset with the object detection task. And the next step is data augmentation. Apply the data augmentation strategies like rotation, flipping, and cropping to diversify the dataset and improve the model ability to generalize the different scenarios. And the next one is processing the data based on the YOLO v5 model. Leverage the pre-trained YOLO v5 model to process the dataset, enabling the accurate detection of shadows and the objects of interest within the image. And the next one is building the model. Here we are building the two models. The first one is YOLO v5. You only look once version 5 is a state-of-art object detection model known for its speed and accuracy. It operates by dividing the image into a grid and predicts the bounding box and the class probability for the object within each cell. And the context of the computer vision based method for the shadow detection project, YOLO v5 is a powerful choice for the detecting the shadow due to its real-time performance and the ability to handle the multiple object classes. The YOLO v5 architecture can be fine-tuned on the shadow detection dataset to specialize and identify the shadow instance within the images. Its streamlined design and efficiency make it well suited for the deployment in the applications requiring the rapid and accurate shadow detection. And the next one is faster RCNN. Faster RCNN is a widely used object detection model that employs a two-stage architecture. It first proposes a region of interest using the region proposal network and then classify and refine the proposed region. And this project, the faster RCNN can be applied to shadow the detection by training it to identify and locate the shadow within the images. Its multi-stage approach allows for the detailed analysis of the project objectives, making it of the well suited for distinguishing between the shadow and the other objects, while potentially requiring the more computational resource compared to the top YOLO V5. Faster RCNN offers the high detection accuracy, making it a valuable candidate for the precise and reliable shadow detection task. And the next step is user input. By here we need to create a user-friendly Flash-based interface that enables the user to upload the images for the shadow detection, fostering a seamless and interactive user experience. And the next one is the given input processed and with trained model is used for the detecting. Pre-process the user provided input image, apply the same pre-processing step used during the training, then utilize the trained model to detect the shadows, highlighting their presence and the location within the image. And the next one is the segmented each object and put the bounding box. Segment the detected shadow and object of the interest, outlining with the bounding box to visually convey the position and the shape. And the last one is final outcome is displayed through the front end. Present the shadow detection outcome to the user through the initiative front-end interface, providing the visual feedback regarding the detected shadow and enhancing the overall understanding of the scene illumination dynamic. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The sample folder containing of the images that will be used to test the performance of the model, and the static folder containing of the folders like CSS, JavaScript, images, uploads within it, and the template folder containing of the HTML documents. It typically include of home, index, notebook, sign-in, sign-up pages within it, and the YOLO folder containing of the algorithm, and app is an py file which likely contain the information that related to the front-end logic, and it includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appears to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this, it will change the country directory to the code folder path, and then click on the enter button. Here we need to write a command, it is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it will redirect it to this page containing of the title and some information about it, and then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password, and those details are need to be filled. And then click on the login button. Here it will redirect it to this page containing of the choose file and upload buttons. Then click on the choose file button. Here it will redirect it to this folder containing of various images within it, and then select one and then click on the open button and then click on the upload button. Here it is the shadow. In this way we can predict it by using the bounding box around this shadow, and by clicking back and then click on the home button. Here it will redirect back to this page, and by here we can choose another file. I'm selecting another one and then click on the open button and then click on the upload button. Here it is predicted as of shadows. In this way we can detect the shadows by using various deep learning models. And in conclusion, detecting the shadow can be considered as a challenging task. The main reason shadows are difficult to detect in videos or images and their inconsistent nature. Two shadows typically never look alike, and they can vary in shape, size, darkness, and even positioning. Therefore, our objective and this research is to accurately detect the shadows to improve the visually impaired assistive device. Detecting the shadow can help this device reduce the number of directions sent to the user. Our system shows outstanding results most of the time with a good accuracy, aim to improve the avoidance system of the assistive devices for the visually impaired.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.